Alright, ladies and gentlemen, happy Tuesday. I am still sailing the high seas and singing sea shanties and obviously having a great time without you. But of course, I took time out of my busy day to come up with this awesome video for science for you guys. So, in the mechanical systems unit, we're going to be looking specifically at why machines give us an advantage. So, we know that machines help us do things, they make our lives easier, but we're going to look at specifically the physics behind why that works. And before we can really do that, we have to analyze what a lever is, or what the parts of a lever, or the different parts of the simple machine we're going to be looking at. Levers are one of the simple machines out there, simple machine. And they're also the most common type of simple machine that we see in society. A lot of the time, what we think of as a lever, like a seesaw type thing, there's actually a lot of different ways that levers are used that you may not think of. Or there are a lot of things in your life that you may not think of it as being a lever, but they're definitely levers. So we're going to look at the different types of levers today, and just talk about the different advantages they may or may not give us. Before we can do that, though, we want to talk about the parts of the lever. And I know this might be a bit of a review for you guys, but it's important that we're all on the same page as we start talking more and more about levers, especially when I get back next week. So there are three parts to, or I guess four parts to the lever, depending on how you look at it. The first part is the most important, the fulcrum. All right. So the fulcrum is literally just the thing that the lever pivots around. I like to draw them as a big triangle like this, but a lot of the times they don't actually look like that unless you're making a lever that's like a seesaw. But it's always whatever it pivots around, and so that can be a lot of different things, which I'll explain as we go forward. The other parts to the lever that are important are the load. So this here is the load. And it's always the thing that we're trying to lift or the thing that we're trying to apply a force to. Because not all levers are used to lift things. We'll get into that a bit later too. Also important is this. This is your effort force. So think of it as where you push down on the lever. And the load, of course, is the thing you're trying to lift with your effort. Alright? We also always have, and this is why I said I guess there's four parts, is we have this bar here, which we need to rotate around the fulcrum in order to lift this thing. So I guess you could say that there's a straight bar of some kind. Alright. And those are the basic parts of the lever. A few things you need to know as well. The distance from the fulcrum to the load is what we call the load arm, and that becomes very important for us to know about. And the distance from the fulcrum to where we actually put the effort is known as the effort arm. It's important to know this because the relative distance of these two things compared to each other actually changes what the whole lever does for us. Okay, so these are the parts you need to know. These are definitions. They should have them in your reading log, hopefully. All right, let's look at the different classes of levers. The first one, and the one that most people are familiar with, is the Class 1 lever. What differentiates levers from each other is where the fulcrum is located compared to where the load and the effort are. So we just rearrange these three things. Alright, so the Class 1 lever always has the the fulcrum in between the load and the effort. Sorry guys, Mr. T's hockey team is outside. They're just talking really loudly. Anyway, so we have the fulcrum is always in between the load and the effort. And so again, it's the relative position of these things. Think of this like a teeter-totter is an example of a Class 1 lever. A pair of scissors is an example of a Class 1 lever, which obviously doesn't have a big bulky triangle in the middle of it, but if you think about scissors and how it's got a dot there and then the one blade rotates around it, it's the same thing. So we have effort on one side, which is where your hands are on your scissors. You have the little swivel point in the middle, which is your fulcrum, and then you have the blades, which are technically the load, because that's where we're applying the force to. Alright? So those are examples of Class 1 levers. What's cool about class 1 levers is they can either make us lift things easily or lift things much further than we could lift them on our own, depending on what kind of or how we use them. Pliers would be another example of a class 1 lever. Uh, and I'm sure there's much more, and I just can't think of them off the top of my head. But these are some of the major ones that are out there. All right. So just remember, class 1 has the fulcrum in the middle. It's the only one where the fulcrum is in the middle. Class 2 levers have the fulcrum on one edge, and it doesn't matter if it's on this edge or this edge, but as long as it's on the edge. But then there's the load in the middle and the effort on the end. And you might think, I've never seen anything like this, but there's actually a lot of examples of levers that actually take this shape. The most common one is the wheelbarrow. All right, wheelbarrows. I feel like I spelled that wrong, but I didn't. All right, wheelbarrows. If you think about it, you've got your fulcrum being the wheel of the wheelbarrow. The load is whatever you're trying to lift, and then where you put your effort is on the handle. So you lift up, and what you'll notice is that wheelbarrows are really easy to move things with. It's way easier to lift something using a wheelbarrow than it is to lift it on your own. That's because class 2 levers always make it easier to do something, or lessen the amount of force it would take to do something. Another good example is a bottle opener. I know you guys don't drink beer right now, but if you ever bought a glass bottle of Coke or whatever, and you had to use a bottle opener to open it, those are definitely class 2 levers. Alright, next 3 is one that a lot of students, again, think that we don't use very often, but there's actually a lot of them out there. Class 3 levers, I think, are the most common type of lever out there, but often they don't actually look like this, or anything like this. So class 3 levers have the fulcrum on the side, just like a class 2 lever, but this time the effort is in the middle and the load is on the end. Okay? So what happens here is you put your effort in the middle of something to move this usually a really far distance. So what ends up happening is you move your effort a little bit, and this has to end up moving further because of the way the lever is structured. Best examples of this are anything involved in sports. So if you play hockey, a hockey stick is a class 3 lever. The reason I know that is the fulcrum is you. It's your body as you turn. The effort is where your hands are on the stick, and the load is the puck at the end of the stick. So you put all your effort in the middle to move this a big distance. When I get back, we'll start talking about mechanical advantage and specifically why this is really good for something like hockey. But we'll table that when we get back. Alright, there's also a number of levers in your body, and so here's my beautiful drawing of an arm. Alright, and you can tell it's an arm because here's the person's like bicep, tricep, the rest of their arm, the beautifully drawn hand, and whatever the block of wood they're holding. Inside I've drawn the bones because it's actually useful for you to see that, for you to understand why your arm works like a lever, as I was saying. So, there's actually a number of different levers in your arm. There are 2, but still it's more than one. We have the bicep at the front. Alright, so your bicep is here, you guys know that. And what the bicep does is it attaches to your bone like that. So it's going to be hard to see, but this little bit here is where it attaches to your bone. This here is your elbow. So this is the pivot point of your arm. So if you think about it, I'm going to quickly draw this on here. I've got a fulcrum here. I have an effort force here. And I have a load here. So I have fulcrum, effort, load. And so this is a class 3 lever. Because my effort's in the middle. Because this muscle attaches to my bone here. I've got my load here at the end and my fulcrum at the other end. Alright. The other muscle you have in your arm is your tricep, which is back here. And the tricep actually attaches at your elbow, at the back of it. So now you see with this one, I have my fulcrum still there, my load still here, but now my effort is over here. So this is actually class 1 lever because I've got my fulcrum separating my effort from my load. Alright, so your bicep is class 3, tricep is class 2. if my drawing makes 0 sense to you, and I'm going to be honest, I think it's actually a pretty good drawing for me. Page 274 of your textbook has this on it as well. Boom. All right, that's all I've got to tell you guys today. You should have a worksheet to do on identifying levers. So you should be working on that now. It's on the back of your reading log and from yesterday, so you should have time now to get that done. If you have any questions, we'll talk about them when I get back after spring break. All right, have a nice day, guys.